Alright, in class today, and you might be watching this at another time, but in class we got to the point in the PowerPoint about sound and waves where I needed to teach you about the loudness, and I didn't quite get to it. So here it is. We're going to study loudness and decibels, which hopefully you've heard of, and if not, it doesn't really matter, we'll get to it. And your gaze has probably been drawn to this most pernicious element of the PowerPoint slide, the dreaded logarithmic function. And I really feel bad if you feel that it's dreaded, but I know that a lot of people really don't like logarithmic functions. Not quite sure why. I like them, along with their cousins, the natural log and natural exponent. They actually make great dinner time conversation starters. So I encourage you to learn a little bit more about logarithmic functions and the different things it can be used for. What I'm going to do is I'm actually going to start off by focusing on logarithmic functions in general so that you get a better feel for them. And then we'll talk a little bit more specifically about what it means. But before we do that, I just want to make clear why we need this logarithmic function. And it's frankly because that seems to be the way that our ear works. Our ear seems to process loudness of sound or intensity of sound waves based upon a log scale, or at least as near as we can model it to a log scale. So I'm going to switch over and we're going to look at logarithmic functions. Okay, the first thing you need to know is that the logarithmic functions that we're going to be dealing with when we're talking about decibels are going to be all base 10. And what that means is that you don't have to do, well, practically speaking, what it means is that when you try to do this on your calculator, you don't have to do anything fancy, you just press the log button. And what we're going to do is we're going to start off by doing log of 10. And I encourage you, if you don't already have it, get your calculator. It's okay to pause me, I don't mind. So pause me for a second, get a calculator out so that you can follow along. I'm not going to use a calculator because it's going to be very easy to do these once you get the hang of it. So the first thing is we take the logarithmic function of 10. What do we get out? I'm not sure why that happened. We get out 1. Alright, that's pretty cool. What if we do a log of 100? When we do a log of 100, we get 2. Okay, what if we do a log of, I don't know, let's do a log of 1 and see what happens. And when we do a log of 1, hopefully you're going to see that it's going to be 0. And I can kind of go on and say, well, what if we do a log of 1/10? And if you get a log of 1/10, then you can try this one in your calculator. You can maybe make a guess at it. Write down what you think it might be, and hopefully you get that answer out. And I can do all sorts of different ones. Maybe we want to do, oh, I don't know. Oops, yeah, no, that's right. That's 100,000, right? Okay. So 100,000 would be 5. So we're going to have 5 here now as our answer. And hopefully you can see where this is going. So I can rewrite all of these, and that's exactly what I'm going to do. So this is going to be 10 to the first, and I get 1. This is going to be log of 10 to the second, and I get 2. This is going to be log of 10 to the 0th, and I get 0 out. This will be log times 10 to the negative 1, and I get negative 1 out. And finally, lastly, and most importantly, I get log of 10 to the 5th, and I find that I get 5 out. So all that we're really doing, and it's really quite clever, is we have a function now that looks at what you put in, and it just basically takes the exponent down. Now if you do something other than 10, it's a little bit trickier, but it's basically the same idea that it's doing. It's just doing it in terms of how many times do we need to multiply 10 together to get the number. So if you try to do, let's say, a log of 20, log base 10 of 20, what is going to pop out over here is how many times do you need to multiply 10 by itself in order to get 20. And when we looked at 10, how many times do we need to multiply 10 by itself to get 10? The answer is 1. How many times do we need to multiply 10 by itself to get 100? The answer is 2. Well, how many times do we need to multiply 10 together to get 20? Probably going to be somewhere between 1 and 2, and closer to 1. And so if you go ahead and check this on your calculator, you should see something like that. and we find that it's 1.3. So we actually have to multiply 10 by itself 1.3 times in order to get 20. And that's all that the logarithmic function does. So for some reason it gets this bad rap as being a very intimidating function to deal with, but it's actually quite nice. Now, what we do differently with the decibels is when we're using decibels, it's important to realize that the base unit for loudness is not the decibel, it's the bell. But if you're familiar with your metric scale, you have on the one side, you have like kilometers, well, we'll go kilo, and you have, well, I don't know that anybody really knows what the 100 one is. I'm sure some people do. And you've got like deca is the times 10. So this is times 10. This is times 1,000. I forget what the 100 one is for the moment. And then you just have your base unit. And then as you continue to go, you have deci, which is 10 to the negative 1 times. And you have centi, which is 10 to the negative 2, and so on. So basically, the decibel is 10 times smaller than the bell. And so if you have one bell, that's the same as having 10 decibels. So what we're going to do is a bell, the equation for bells would be equal to log of I over I naught. But we don't deal with bells. We deal with decibels, because really what it does, it means we don't have to work with fractions so much. So we're going to do the decibel equation, and I make a little bit of a fancy b there. We have 10 times log of the intensity that you're actually hearing divided by this I naught. And I'm going to go ahead and box this. Okay, so you can put this on your equation cards. And what that means is that if we go back up here for just a moment, if I do 10 times this, I actually get 10. I get 1 times 10. If I do 10 times this one, I get 2 times 10. 10 times this, I get, well, 0. 10 times this, I get negative 10. 10 times this, I get 50. So we're just multiplying whatever our outcome is by 10. And what this means, if we just look at this one's a pretty easy one to look at. On the decibel scale, we've gone from 10 to 20, so we've doubled the loudness. And what's interesting, to me at least, is that in doubling the loudness, we didn't double the amount of energy that's involved. This is more representative of the actual energy that's involved. So we went from an energy of, let's say, 10 to an energy of 100. And that's not doubling. That's multiplying by 10. So when we double from 10 to 20, we actually have 10 times the amount of energy present. And you can see what happens then too. If we go from 20 to 40, so 10 log of 10 to the 4th would be 40, and that's 10,000. So we go from 100, actually 10 here, we go from 10 to 10,000. So that's 3 times, or I'm sorry, that's 4 times the loudness, but it's going to be 1,000 times more energy involved. If we're looking at 10 to 10,000, that's 1,000 times more energy involved, but we only went from 10 to 40 decibels. So it's 4 times louder, but it's 1,000 times the amount of energy. And that's the amazing thing about our ears. So they take this signal that's 1,000 times more powerful, and they only make it so that we hear it as about 4 times as loud. So what we're going to do then is, let's just do a quick little equation here, and let me emphasize what this is. So this I naught is equal to 10 to the negative 12th watts per meter squared. And this I naught, by the way, it's not moment of inertia, it is called intensity. And it is measured in watts per meter squared. What I'll do is I'll continue this lecture in another video, and I'll take you through a little bit more detail about what intensity is, what it means, and show you an example of the decibel scale so that you can get an idea of how it works.